right, so this is Module 3 for Chapter 11, and this module is over tangents and circles and what those go together with. This goes in your notebook on page 156 and 157, and I have a picture here so you can kind of have an idea of how it should look in your notebook. You have the flaps with the pictures drawn underneath it, some problems we work out, and then some more problems over there. All right. So the first thing we have is a few theorems that we want to talk about. The first one says, if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So here I have a circle and a line that is tangent to it. And that means that if I draw a radius from the center to the point of tangency, it's going to be perpendicular or make a right angle. It's going to have 90 degrees. And then the second one is the converse of that. It says if a line is perpendicular to a radius at the endpoint on the circle, then the line is tangent to the circle. So these two just basically say, if I know it's tangent, then I can draw the right angle. If I see the right angle, then I know it's tangent. So it's the converse of each other. And then the second one, it says if two segments from the same exterior point are tangent to a circle, then they are congruent. So notice we have an exterior point, we have two spots that are tangent to the circle, and that means that the distance from A to B is the same as A to C because they're both tangent to the same circle. Now we're going to do some problems that have to go with this. So here they told us these are all tangents, so we're just going to know that they're tangent. If they look tangent, they are tangent. Okay, so B is tangent, which makes this a right angle. Do you see how this is really just Pythagorean theorem? A squared plus B squared equals C squared. So if that's the case, X is my hypotenuse. And so I'm going to use Pythagorean theorem to solve. So X is what we're looking for. 3 and 5 are my two sides. 3 squared is 9. 5 squared is 25. 9 plus 25 is going to be 34, which means that X is going to equal the square root of 34. And if we check, we can see that the square root of 34 doesn't simplify. So that was either the first theorem or the second theorem, depending on how you want to view it. Then problem number 2. I have an exterior point. These are both tangent to the same circle. That means this side is equal to that side. So 2x minus 5 equals x plus 12. That should be super easy to solve. So we're going to go ahead and solve for x. Subtract 1x from both sides. Add 5 to both sides. Here I get x, because that cancels, equals, and then 12 plus 5 is 17. So that's how we get x equals 17. All right, next problem. Same thing again. Here's our right angle because B is tangent to the circle. And this is, once again, a Pythagorean theorem problem. C, my hypotenuse is 16. So I'm going to use Pythagorean theorem to solve this problem. So 9 squared is 81. And 16 squared is 256. And then I subtract these two. And so 256 minus 81. So let's just do that subtraction problem here. So I see that we have 5, 15, that's 7, 175. So this is 175, so that means x equals the square root of 175. I want to see if 175 reduces. So I know that 25 goes into 175, and I know that goes in 7 times. And then 25 is 5 times 5. So I can see that this is 5 root 7 is the value for x. Okay, now we have 3 more problems to solve. This one is like the other one where we have an exterior point and its 2 points are tangent, both tangent to the circle, so we're going to solve for x. So 3x equals x plus 18. Subtract 1x, 2x equals 18, x equals 9. Then the next one, hopefully you can see B is the one that's tangent to the circle. So that's my right angle, which makes this, my hypotenuse, now this one is a little bit trickier because 8 is just this outside part, which means I have to include the radius again. So my hypotenuse isn't 8, but it's 8 plus 5, which is 13. So I'm going to use Pythagorean theorem here. One leg is 5. My hypotenuse is 13. 5 squared is 25. 13 squared is 169. So 169 minus 25, we get a 4, 144. And that means that the other side, x, is going to be 12. Notice how that was a little bit tricky though, because 8 was just this outside piece, not the whole hypotenuse. All right, problem number 6b is once again the tangent point. Okay, I can see that this little piece is 4, this piece is x here, and this piece is x. So this one is a little bit tricky because I have different sides. So I'm gonna just write this out to make sure I understand. Okay, so my hypotenuse is x plus 4. Ooh, that doesn't look good. Then one leg is x and the other leg is 8. 8 squared is 64. Okay, and then x squared is x squared, and then x plus 4 squared, that's not even fun to square. We have to use FOIL. All right, so when we FOIL this out, we get, that's the same thing as going x plus 4 times x plus 4, so we get x squared plus 4x plus 4x plus 16. Okay, so that's what these two we have to figure out. So a squared is 64 plus b squared equals x squared plus 8x plus 16. Okay, if I write it like that, it might be a little bit easier for me to see how I can solve for x. When I want to solve for x now, I'm going to subtract an x squared from both sides. So now I have 64 equals 8x plus 16. I subtract 16 from both sides here, and I get 48 equals 8x. Divide by 8, and can you see how now x is going to be 6? That's how we solve that one. So that one was a little bit trickier with Pythagorean theorem because we also had to FOIL. All right, now try page 157 on your own. So pause it, try them out, see if you can understand them, okay? Once you do, we're gonna go over the answers to these problems. All right, so these are the answers now. Hopefully you tried them out to work them out on your own. Check to see if you got the right answers. If you didn't get the right answers, the next time you come into class, make sure you ask questions to make sure you understand how to get these answers for page 157 in your notebook. That's the end of Module 3.